We hear all the time, right? Today's AI models are basically digital geniuses. But what if their greatest strength, that incredible solo intelligence, is also hiding a critical, and I mean critical flaw? Today, we're diving into some new research that reveals why these brilliant minds might actually be terrible teammates.
I mean, you've seen the headlines. AI models from places like OpenAI and DeepSeek aren't just solving problems. They're acing university-level math and spitting out flawless code. They show their work, they fix their own goofs. They are, by pretty much every measure we have, these amazing solo performers.
But what happens when they're not working alone? What if they have to pick up where someone else left off or get thrown a total curveball? Well, that's where things start to get interesting. That's where the cracks in that genius persona really start to show. So to really get what this flaw is all about, we first have to see them do what they do best. We've got to look at how they perform on their own, what the experts call solo reasoning.
This is basically the standard way we train and test AIs right now. We hand them a question, and they generate the whole thought process, from start to finish. It's a one-man show, a solo performance, and it's what all those big, popular benchmarks are designed to measure.
And hey, the results? They speak for themselves. I mean, just look at these scores. You've got models like AM Thinking 32B hitting over 80% on math benchmarks that would make a college student sweat. These things aren't just smart, they're like certified solo geniuses. But the real world, it's rarely a solo gig, right? It's messy, it's collaborative. So researchers came up with a new kind of test to see how these AIs actually handle teamwork and, interruptions. This was the big question in their paper. Now, off-distribution trajectory, yeah, it's a mouthful. But all it really means is a thought process that the AI didn't cook up itself. So can it grab a line of reasoning from another model or maybe even a person and just run with it? That's the test. To figure this out, they designed two really clever twin tests. One was to see how resilient they are against bad info, and the other, to see if they could actually accept good info when it's handed to them. All right, let's look at the first one. They called it the recoverability test, and this is all about how well an AI can handle getting knocked off course. Here's the setup. First, they let a model start solving a problem it already knows how to crack, simple enough. Then, right in the middle of its work, they sneak in a random, totally misleading chunk of text from a different problem. So the big question is, can the AI spot this nonsense, ignore it, and get back to its original, correct train of thought? Okay, now for the second test, the guidability test. This is pretty much the flip side of the coin. It's not about ignoring bad advice. It's about being able to take good advice. So for this one, they give a model a problem that's way too hard for it. It's designed to fail on its own. But then they give it a perfect, correct first step, like a helpful hint, from a much smarter AI. And the whole test is just to see if the model can take that hint and use it to solve a problem that was impossible for it just a moment before. So, how'd they do? Well, their results are, and I'm not exaggerating, genuinely shocking. Let's take our champ, AM Thinking 32B, scoring over 82% on the normal benchmark. But the moment you toss in a simple, irrelevant distraction, its performance just plummets, down to 25%. That's like watching an Olympic sprinter trip over a pebble. It's a catastrophic failure. And this wasn't a one-off. This pattern held up across the board. Just look at this table. The top-ranked model, AM Thinking 32B, drops 13 spots in the rankings. It becomes one of the worst collaborators. Again and again, the supposedly stronger the solo performer was, the more fragile it turned out to be. So being a solo genius, it turns out, does not make you a resilient thinker. And if you thought that was bad, oh boy, the guidability results were even worse. When these models were stuck and got a perfectly correct hint, the absolute best any of them could do was succeed less than 9.2% of the time. Less than 10%. And get this. This is the crazy part. The researchers found that even when the hint literally contains the final answer, most of the models would still ignore it. They'd reject the correct information and just stubbornly go down their own wrong path. It's like they're trained to only trust their own thinking, even when it's leading them off a cliff.
Okay, so this just begs the question, why? Why is this happening? Why are our smartest AIs so brittle? Well, the researchers decided to dig into the training process itself to find the root cause.
And they narrowed it down to 3 key things: the teacher model they used to train smaller student models, the specific training technique, like reinforcement learning, and finally, how they choose the training data in the first place. Okay, first up, they found that this weakness is basically hereditary. If you use a teacher model that's bad at recovering from distractions, well, its student model inherits that same exact flaw. The bad habits just get passed right down, even if the student only ever sees correct examples. Second, the training method itself is absolutely crucial. The standard way, SFT, is kind of like giving a student just the answer key. Sure, they learn the right answers, but they don't learn how to actually problem solve. But a different method, reinforcement learning, or RL, acts more like a coach. It actually rewards the student for getting back on track after a mistake. And just using that method improved recoverability by almost 29%. It explicitly teaches the AI how to be resilient. And finally, they looked at the data. There's this popular strategy called less is more, where you use a very small set of super high-quality data. What they found is that this creates models that are amazing at acing tests, but are just wildly unpredictable when they make a mistake. It turns out, bigger, more varied datasets actually lead to more stable and robust models. So, what does all this mean for the future of AI? Well, it means we might need to seriously rethink what we're building here. This quote from the paper just nails it. By focusing so hard on making AIs that can crush tests all by themselves, we might be accidentally building in these hidden vulnerabilities, flaws that only pop up when they have to interact with the messy, unpredictable, collaborative real world. And that leaves us with a really big question, doesn't it? For years, we've been training AIs to be these brilliant soloists, the smartest mind in the room. But maybe what the world actually needs isn't another lone genius. Maybe it needs a better teammate. Perhaps the most important skill we can teach an AI isn't just how to be right, but how to work well with the rest of us.